These are the solutions to the Unit 1 mid-unit assessment review that we are going to be giving to you. Being able to understand all of the questions on this review means that you'll be very well prepared for the Unit 1 mid-unit test on Tuesday, September 15th. So let's get to it. Number one, we're asked to find the area of the given figure, which is a composite figure, so we need to decompose it into shapes that we have formulas for. At this point, we have shapes for rectangles, parallelograms, and triangles. So I'm going to decompose this into one rectangle and two triangles. The rectangle is 1, 2, 3, 4, 5, 6 units by 1, 2, 3, 4 units. 6 times 4 is 24. The area of the rectangle is 24 square units. For the triangle, we can call this the base and this the height, because we can count those on the grid. The base will be 1, 2, 3, 4, 5, 6 units, and the height is 1, 2, 3 units. Remember that the formula for a triangle is base times height divided by 2, or you might have seen it as 1/2 times the base times the height, since multiplying by a half and dividing by 2 do the same thing. 6 times 3 is 18, and 18 divided by 2 is 9. So the area of that triangle is 9. And the bottom triangle, we'll call this the base and that the height, because there's that right angle, and we can count those on the grid. The base is 1, 2, 3, 4, 5, 6 units, and the height is 1, 2, 3 units. That's the same dimensions as the top triangle, and so they have the same area, which is 9. And so to put it all together, we have 24 plus 9 plus 9, and that all adds up to 42. So the area of this figure is 42 square units. Number two, we're given two triangles. We have one side of the triangle that is labeled the base, and we are asked to draw in the corresponding height and label it with an H. So let's start with the triangle A. If this side is the base, then the corresponding height needs to go from the opposite angle straight down to the base to make a right angle. So that is what the height of that triangle will look like. For triangle B, if this is the base, then the height needs to go from the opposite angle straight down to make that right angle. So in this case, we need to extend the base of the triangle in order to be able to have the base meet the height. And so that's going to be the height. Number three, we're asked to find the area of this parallelogram. And we are given the length of both of the bases, and we are given the height. I see the right angle right there, and so I know that 6 centimeters is going to be the height that I should use. And that line segment connects these two bases, which means 9 is the base that I should use for the area of this parallelogram. The area of a parallelogram is base times height. 9 times 6 is 54. So the area of this parallelogram is going to be 54 square centimeters. And then we're asked what could be the dimensions of another parallelogram that would have this same area. Well, since we multiply the base and the height to get the area, which is 56, other parallelograms that have an area of, 54 square centimeters, other parallelograms that have an area of 54 square centimeters simply need to have a base and a height that is a factor pair of 54. Here are some examples. The base could be 54 and the height could be 1, or the height could be 54 and the base could be 1. The base could be 27 and the height could be 2. The base could be 18 and the height could be 3, or vice versa, and so on and so forth. Number 4, we're asked to draw two distinct parallelograms. That means two parallelograms that are different shapes, but both parallelograms need to have an area of 12 square units. Parallelograms should not be identical copies of each other. So that means we can't draw one parallelogram and then simply rotate it and say that we have drawn another parallelogram because we haven't. We've done the same one. All right, remember that a parallelogram simply needs to have the opposite sides parallel to each other and equal in length, both pairs. So we could have a 3 by 4 rectangle because 3 by 4 will make 12 units. So there's a 3 by 4 rectangle right there, and it is a parallelogram because opposite sides are equal and parallel, and its area is 12 square units. Now I want to make another parallelogram. I want to use the same dimensions, but I want it to look differently. So here's what I can do. I can have 3 units be the base right there, and then have 3 units be the height, or sorry, the other base right there, and then I will connect those. That still has an area of 12 because the base is 3 units, and if I draw the height in, right there, the height is 4 units. 3 times 4 is 12. So here's just 2 possible ways to think about this question. Number 5, select all the parallelograms that have an area of 8 square units. Parallelogram A has a base of 4 units and a height, there's the right angle, of 2 units. 2 times 4 is 8. So parallelogram A is good. Parallelogram B, we will call this the base because we can count along the grid lines. And this will be the height right there because we can count along the grid lines. The height is 2. 1, 2, 3, 4, 5. The base is 5. 2 times 5 is 10. Parallelogram B is not 8 square units. And for C, we're going to call this side, these two sides, I should say, the bases, because we can count on the grid, which means the height will be the line segment that connects those two to make that right angle. The height is 1, 2, 3, 4 units. 2 times 4 is 8. Parallelogram C is also 8 square units. And number 6. We're asked to find, well, we want to know how many square yards of gold paper is going to take to cover all of this arrow. Square units indicates we're finding area, so we need to find the area of this composite figure. So I need to divide it into figures that we have formulas for. We have formulas for rectangles, parallelograms, and triangles. And if I cut this figure right there, that makes one rectangle and one triangle, so that means I'm good to go. So let me start with the rectangle. The rectangle has a base of 6 yards and a height of 6 yards. There's that right angle in the bottom right corner. 6 times 6 is 36. So we have 36 square yards for the rectangle, which happens to be a square. All right, now for the triangle, we see that the height is going to go from this opposite vertex straight down to make the right angle. And that height that I just drew in is the same length as that line segment right there. So the height of the triangle is 9. And now we need to figure out the base of the triangle. We have these 2 little pieces on the ends here that are each 3 yards. So we just need to figure out what this piece in the middle is. Since the bottom shape is a rectangle, we know opposite sides are equal in length, which means that side of the rectangle is also equal in length. So we have 3 plus 6 plus 3 is 12. The base of the triangle is going to be 12 yards. So for the triangle, again, we have base times height cut in half, or base times height times a half divided by 2, and multiplying by a half does the same thing to a number. So I've got 12 times 9 divided by 2 or multiplied by half. And that is going to be equal to 54. You can verify that with a calculator if you need to. So we got 36 square yards for the square on the bottom, plus 54 square yards for the triangle on top. 36 plus 54 is equal to 90 square yards. If you do all 6 of these problems, then you should be very well prepared for the test on Tuesday. I hope this was helpful.